No need lithium. Donut Lab confirms the world's first true solid-state battery, and Toyota is officially on alert for decades. We were told the same story. Lithium is the future. Lithium is unavoidable. Lithium is the bottleneck of the electric revolution. Governments built strategies around it. Automakers bet entire product lines on it. Mining companies raced across continents to dig it out of the ground. And consumers were quietly taught to accept the trade-offs: limited range, slow charging, thermal runaway risks, degradation over time, supply chain dependence. All of it was framed as the cost of progress. But what if that entire assumption was wrong? What if lithium was never the end game, just a temporary bridge? And what if a relatively quiet engineering group, not a legacy automaker, not a Silicon Valley giant, but a deep tech lab most people have barely heard of, just proved it? Today, Donut Lab is claiming something that would have sounded impossible just a few years ago: a fully solid-state battery. No liquid electrolyte, no lithium dependence in the traditional sense, no thermal instability, no fragile chemistry, and according to early data, performance that doesn't just compete with lithium-ion but threatens to make it obsolete. This isn't a concept render. This isn't a lab-only prototype that might work in 10 years. This is a system designed to scale. And yes, Toyota is watching very closely, because for the first time, the company that has spent billions chasing solid-state batteries may not be leading the race anymore. It may be reacting. Let's slow this down, cut through the hype, and understand why this announcement is different and why it could quietly rewrite the future of energy. For over 30 years, lithium-ion batteries have dominated everything from smartphones to electric vehicles. Their chemistry is well understood, their manufacturing processes refined, and their limitations painfully familiar. At the core of every lithium-ion battery is a compromise. Liquid electrolyte. It allows ions to move quickly, but it comes with serious drawbacks. It's flammable. It degrades over time. It requires complex thermal management. It limits energy density. Most importantly, it forces manufacturers to design batteries around safety rather than pure performance. Solid-state batteries promise to remove that compromise entirely, replace the liquid electrolyte with a solid material, and suddenly the entire architecture changes. Higher energy density, faster charging, no leakage, no fire risk, longer lifespan. On paper, solid-state batteries have always looked like the holy grail. In reality, they've been painfully difficult to make work outside a laboratory. Interfaces crack, materials expand and contract. Ion mobility drops, manufacturing costs explode. This is why even Toyota, arguably the most disciplined engineering company in the auto industry, has repeatedly delayed its solid-state timeline. Each breakthrough created two new problems. Until now, Donut Lab's approach is fundamentally different from the strategies we've seen before. Instead of trying to force traditional lithium chemistry into a solid format, they rethought the system from the ground up. Different materials, different architecture, different assumptions. The result is not just a battery, it's a platform. At the heart of Donut Lab's S-system is a solid electrolyte structure that maintains high ionic conductivity without relying on volatile liquids or rare lithium formulations. This matters more than it sounds. One of the biggest challenges in solid-state batteries has always been ion transport. Liquids naturally allow ions to flow easily. Solids resist that movement unless engineered with extreme precision. Donut Lab claims they've solved this with a proprietary composite solid electrolyte that remains stable across wide temperature ranges, while maintaining conductivity comparable to liquid systems. If that claim holds up under independent testing, it changes everything, because once you solve ion mobility, a cascade of benefits follows. You can increase electrode thickness without sacrificing performance. You can reduce internal resistance. You can eliminate bulky cooling systems. And suddenly, the battery pack becomes smaller, lighter, and simpler. But here's where things get truly interesting. Donut Lab isn't just talking about performance. They're talking about manufacturability. Most solid-state startups hit a wall when they try to scale. Exotic materials, ultra-precise fabrication, and low yields make mass production impractical. Donut Lab says their battery architecture is compatible with modified versions of existing battery manufacturing lines, not entirely new factories, not billion-dollar greenfield investments. Modifications. That single detail is why established automakers are paying attention, because it means this isn't a moonshot, it's a transition. And that's where Toyota enters the story. For years, Toyota has been the loudest and most consistent voice promising solid-state batteries. They've filed thousands of patents, teased prototypes, and repeatedly claimed breakthroughs. But Toyota's timeline has always been conservative. Mid-2020s became late 2020s, then early 2030s. And even now, Toyota admits that large-scale deployment remains a challenge. Donut Lab's announcement puts pressure on that narrative. Not because Toyota suddenly failed, but because someone else may have cracked a different path. Toyota's approach has largely centered on sulfate-based solid electrolytes. These offer high conductivity but come with their own challenges, including sensitivity to moisture and manufacturing complexity. Donut Lab appears to have bypassed those constraints entirely. Different materials, different failure modes, different risk profile. From an industry perspective, this is unsettling, because incumbents don't fear incremental improvements, they fear paradigm shifts. If Donut Lab's battery truly eliminates the need for traditional lithium supply chains, The implications extend far beyond electric vehicles. Energy storage for the grid, aerospace applications, marine propulsion, heavy industry. Entire sectors could decouple from lithium price volatility and geopolitical constraints. That alone explains why this announcement is being quietly scrutinized rather than loudly celebrated. Now, let's address the elephant in the room. Is this real or just another overhyped battery claim? Healthy skepticism is not only reasonable, it's necessary. The battery world is full of promises that sounded revolutionary and went nowhere. So what separates Donut Lab from the noise?